He's recording.
So for this problem, what we're going to have to do, just think back to like a regular problem, like 2/5 minus 3, let's say, sevenths. How do you add or subtract fractions?
You have to find the common denominator.
Find common denominator, but I'm going to have to multiply. When I find the common denominator, I'm going to have to multiply that.
The numerator and the denominator.
Right. So this is 7 and this is 5 that I need to add to this. So it's the same concept, but I first have to factor this and factor this. Find the common denominators and solve. Let me make these a little bit bigger so it's easier to do. So this first one right here is going to be x plus 5, x plus 1. And this one right here is going to be x plus 1, x plus 2, or x minus 1. And what you'll notice is they both have the same factor there of x plus 1, which means we don't need to multiply the top by that extra factor. So what's the least common denominator for this entire problem?
X plus 5.
No,
And
the least common denominator.
X plus 1.
No, the least common denominator is x plus 5 times x plus 1 times x minus 1. It's all three of those.
Why?
I need an x plus 5, I need an x plus 1, and I need an x minus 1.
Okay.
For the same reason, let's look at an old problem. If I had let's say 2/5 minus 3, 2/5 is a bad example. 2/15 minus 3/20. If I had 2/15 minus 3/20, well, this right here has a factor. They both have a factor of 5. This has a 3 and a 5. This has a 4 and a 5. So what do I need to multiply this top by over here? I don't need to multiply it by 20 because it already has a 5. I only have to multiply it by 4 on the top and the bottom. And what do I have to multiply this one by?
5.
It's only, nope, it already has a
3.
5. I only have to multiply it by 3 on the top and the bottom. The GCF is 60. 20 times 3 is 60. 4 times 15 is 60. So what do I have to multiply this one by? Up here on the top, I have to multiply this by, what's it missing?
X plus 5.
I have to multiply it by x plus 5 on the top and the bottom. And what do I have to multiply the first term by?
X minus 1.
X minus 1, because that's the only one that it's missing. So when I do that, I get 2 times x minus 1 minus 3 times x plus 5 all over that denominator. And now I can just simplify this. That's 2x minus 2, negative 3x minus 15. Don't forget to distribute that negative in there. Now add like terms. Positive 2x minus 3x is negative x. Negative 2 minus 15 is negative 17, all over x plus 5, x plus 1, x minus 1. And there's your answer. Alright, so now let's take a look at a complex fraction. This is sometimes for people the trickiest thing, but it's really not all that bad. Let me teach you the best possible trick to doing this problem, and it's called clearing the fraction, CTF. Here's what you do. You multiply the top and the bottom by the least common denominator, which is x squared. And the reason I'm going to do that, check this awesome stuff out right here, is because when I do this, it will make this problem way easier. Watch what happens. When I notice I'm going to distribute this x squared into here and into here, and tell me what I'm going to get. 3x squared. One of the x's is going to cancel with this one when I do it there, so it's going to be 12x. X squared minus 16. That looks like a much easier problem now, doesn't it?
Yes, it does.
And now I factor an x, a 3x out of the top, and I get an x plus 4. Factor the bottom factors by difference of perfect squares. And now I can doink doink, done. 3x over x minus 4.
You're joking.
Alright, here's another complex fraction. Let's simplify this. Again, the trick for these problems, multiply by the greatest or least common denominator, which in this case is just x. You see how there's an x here and an x here? So if I multiply everything on the top and bottom by x, watch how sweet this is. That is going to cancel, and I'm just going to get an x minus 1 on the top. And on the bottom, notice I'm going to have to distribute it. Don't forget that. So when I distribute that in, I'm going to get an x here, and these are going to cancel, so it's just minus 1. And what do we have here?
You're kidding
X
me.
minus 1 over x minus 1 is what?
1.
1.
That's nuts.